Well, hello students. Today I will start to show you the problem right here for the beginning and the end for a specifically digital problem, right? Um, the problem consists like this. They must to obtain a circuit, right, that satisfies the following combination in the output. Combination 0, 1, 2, 5. This This combination we call in the midterm of the output. The midterms are associated with the sub design. Just remember, sub is sum of product. What is the midterms? The midterm is the ones of the output. So look at right here. Right here, number one is combination 0. We have 1 in combination 1. We have another one in the output in combination 2, and we have the last one ones in the output in combination 5. So that's what I mean. The midterms are the ones of the outputs expressed in this combination, right? So we start with the first one, and we see A inverting A, inverting C, inverting B, inverting C is the first one, right? Plus the second one is inverting A, inverting B, C, inverting A, inverting B, C is the other one of the output. The third one is inverting A, B, inverting C, inverting A, B, inverting C, and the last one is A, inverting B, and C, A, inverting B, and C. So there are 4 midterms in the output, right? And now we start to combine it together, right? With to obtain the common factors that they have. We start to make some groups. The first group is number 1. These two items has in common what? A inverting and B inverting. C plus C. If we can use distribution property, we can go back right here, right? That's the idea. Simplifying. The second one is inverting A, inverting B, C with A inverting B, C. What is the common factor of these two items is inverting B, C, right? With A inverting plus A. And the last group is inverting A, inverting B, inverting C with inverting A, B, inverting Z. And the common factor that they have are inverting A, inverting C, right? B inverting plus B. We have to remember that this is the property of OR with C inverting plus C is equal to 1. So immediately this part right here is multiplied by 1, and it is finally go right here, inverting A, inverting B, the same one, the second one, inverting BC, and the same one, the last one, inverting A, inverting C. So we obtain the simplification of the function, right? We go into the software. Well, we already drawing the software right here in LogicSim, remember? And we start to go to the simulate and check and analyze the circuit, right? We go into this part of the software and then shows the table, which means is the true table of the circuit. And we observe that we have the same output as the design is. So the process is correct, right? Why is correct? Because we designed the simplified form, and we obtain the same result with a big one. right? All right. Now, the last part of the problem is we need to create the schematic of the circuit. To do that, we already know a package, right? Those packages was explained in previous lessons. The first package right here is the 7408, which is a X inverter. It has 6 inverters integrated in the package. As you see, the pin 14 goes to VCC of 5 volts, and the pin 7 must go to the ground in order to energize these chips. All chips have the same property. The pin 14 must be a 5 volts and 7 goes to ground. The second one chip right here is the 748 and 7408, which in quad 2 input inverting. Quads means 4. 2 inputs is because each one gates have 2 inputs. AND gate. And the last one is the 7432 quad 2 input OR gate, right? And together in that particular position is required to create sum of product. Must be aligned like this. The first one must be the 7404, the hex inverter. The second aligned chip must be the 7408, which is the quad 2 input AND gate, and the last one is the 7432, the quad 2 input OR gate. We start to see the logic diagram right here. The first AND right here need inverting A and inverting B. So we going right here. By the way, A, B, and C are switches, right? That can change to 0 to 5, depends on the position, right? These switches are the inputs, right? It can combine the 0 to 7. They have 8 combinations, 8 different combinations. 3 switches create 8 different combinations, right? Right. And then we start to create the schematic. We observe the first AND must be to A inverting, so we need to touch a cable right here and send the output of the switch in the input of pin 1 on the inverting one for this chip, and the output of this must go into the AND right here. Look at that. The pin 1 on this end of have 8 inverting. Why? Because you send right here 8, and the output of the one is A inverting. We go in this cable and put it right here. The other one is what? Inverting B. So we must invert the input B through to the inverter. The output of the inverter right here is B inverting. So this is the input right here in this end, right? So we have A inverting, B inverting. The output of this AND must go to the word, to what? To the input of this OR, right? Oh, well, we have a little problem right here. What is the problem? We have a 3 input OR, but our chip is 4 gates, each one with 2 inputs. It's no problem. What we have to do is the output of this OR must be input for to the other one near OR. In that way, you can convert 2 ORs with 2 inputs in 1 OR of 3 inputs. The 3 inputs are 1, 2, and 3 right here. And the output is the last one right here. Right? You have to remember this very well. Alright? Now we continue to the second AND right here. The second AND said that need B inverting also with C. Here we go. We see the second AND right here, and we see that need have B inverting, right? we follow the green lines. Alright, oh, this is B inverting because the input is right here, B. Right? So this is B inverting, and pin 5 right here goes directly to where? To C. Alright, this is B negative, C. B negative, B inverting with C. Alright, we already have that. The output of the AND goes where? Oh, put the second input they are right here. Now the last one is last one AND gate, the logic sim, indicate that need B inverting, C inverting. Need what? Need. No. Let's see. No, this one need A inverting with C inverting. Follow the lines. Alright. Need A inverting. Well, this is A. A inverting must be this blue line. Here we go. This a dot indicate that is a hard connection. So therefore it's a inverting input right here. And the purple line right here indicate the come from here, and the input is where? C. So therefore this is C, and therefore this is inverting C. So this is the input of the last AND right here. This line has the following: A inverting, C inverting. So the output of this AND is the input of the third of this OR right here. And finally, the output is obtaining on the pin C right here. And this is the schematic, right, of this logic diagram. Don't confuse. This is a schematic because you have the package switches right here, integrated circuit, and you need to combine it according with the logic diagram that you design. So this is your alarm, all right, that can be on the following combination, right? And you got the system, right? So I believe this is the entire process. First, we need how the combinations we want to detect, right? We want to the system turn on when A, B, C are off, when A, B, and C on, when A on, B, A off, B on, and C off, and A on, B off, and C off. I'm sorry, A on, B off, and C on. The other ones must be in zero. Can't start. This is made it using all the theory that I show you in this model learning. Well, I hope you understand that. Just remember, my name is Leandro Morales from Polytechnic University of Puerto Rico, the Office Department of Electrical and Electronic Engineering.